So in this video, we are going to look at area and how to find the area when our curve is both above and below the x-axis. And we're looking at the actual area and not the net area. So just as a reminder, when our function is completely above the x-axis, and it can intersect the x-axis, but when it is a continuous non-negative function, we said that the area of this function, the area between that and the x-axis, is the same thing as our integral. But we said if our function is below the x-axis, then we know that the definite integral is going to be negative. So if we want the area, you can kind of think of it in three ways. You can think about, okay, I need the opposite of the definite integral because the definite integral is negative if my curve is completely below the x-axis. Or I can take the integral and then do the absolute value of it to make it positive. Or you can take the absolute value of the function, which reflects it over the x-axis. So this would be the function y equals the absolute value of f of x, and then take the definite integral of that. Now to do this, we usually can use the calculator command, which I will show you. You can't really do the actual absolute value by hand. So just as a reminder, we said the integral gives us net area, and we looked at this picture before and we said this integral from a to b would be all of these integrals separated, added together, where below the x-axis, like a and c would be considered negative and b and d would be positive. So if we want the actual area and not the net area, what we'd have to do is any that are negative, we'd have to make positive. So we would be doing like the absolute value from a to b of f of x dx. And then we can say the absolute value from c to d as well if you want, but because it's positive, we don't have to. Plus, okay, this one is negative from d to e. So I would have to take the absolute value of this one to get the area. And then our last one from e to b, the function is above the x-axis, so it would just be the same thing as the definite integral. So what we're going to do if our curve goes both below and above the x-axis in the region we want, we're going to find the x-intercepts, which is where it crosses the x-axis, and we're going to separate our function and take the definite integral from the start to like the first x-intercept, and then if between the x-intercepts, and then from the last x-intercept to the end of our interval. And then we will take the absolute value of any of the negative regions and add them all together. So let's look at an example. So we're going to do f of x equals x squared minus x. We want to find the area bounded by the curve and the x-axis from 0 to 2. So first off, you probably want to graph these in your calculator. You also need to find the x-intercept. So you can either do that looking at the calculator, or you can set your function, if you prefer like things algebraically, you set your function equal to 0. You factor, so this you can factor out an x. And then you set each factor equal to 0, and that would give you your two x-intercepts. So I get x equals 0 and x equals 1. So it gives you just kind of an idea of where our function crosses the x-axis before graphing it. But to graph it, you go to y equals, you type in this x here, this is our variable, squared, minus x, and then we're going to graph it. So generally to graph, you hit zoom and then standard to get kind of an idea of what it looks like, but we need only from 0 to 2. And because we already found the x-intercepts, we know it crosses the x-axis at 1, so we need to be more zoomed in. So what I would do is for your window, we want our x to be from 0 to 2, I would do a little bit below 0 and a little bit above 2 to get a better idea. So maybe like -2 to 4, and then graph it. And you can kind of see this is below the x-axis, but it's not really easy to see. So maybe we change our y scale to be a little bit closer. So we could try like -5 to 5 and see if that gives us a better idea. And then you can see here's below and here's above. You can also hit second table to get an idea of values. So we have 0, 0, 1, 0, 2, 2. So that's how I graph these. And then we know it goes below the x-axis from 0 to 1. I don't really care what the height is, so I just estimated it. And then above from 1 to 2. So when we are finding the area under this curve, we can't just take the integral from 0 to 2 of x squared minus x, because it's going to make this negative, this positive, and give me the net area, which is not the same thing as the area in this case. So what we have to do is we have to do two separate integrals. So we're going to take the integral of where it goes below the x-axis. So we're starting our region at 0. And we go to where the x-intercept is, which is at 1 of our function. And we know this is going to be negative. So to get the area, we will have to take the absolute value of our answer. And then we're going to take the integral of this second region. So from 1 at that x-intercept again to where we're ending, which is 2 of the same curve. And that's going to give me this area up here. And then we will add those two together. So these get long when we do it, so you might want to do them kind of separate and then add them back. So if I just start with the integral from 0 to 1 of x squared minus x dx, what I can do is I'm going to take the integral of both of these. So x squared, we add 1, so it's x cubed over 3. Minus, this is a 1, so we add 1, x squared over 2 from 0 to 1. And then we're using this fundamental theorem of calculus. So for that, we plug in our upper bounds. We get 1 cubed over 3 minus 1 squared over 2 minus, and then we plug in our lower bound. Okay, and some of you might be able to tell right away that our lower bound is just going to be 0 because it's in every term, which is perfectly fine. You can not put that if you want. Okay, so we get 1/3 minus 1/2 because this is 0, which is -1/6. And we knew it would be negative because it's below the x-axis. So remember, for this part, we will have to, when we're doing the area, take the absolute value of that. Okay, let's find the other integral first and then come back to that. So for the integral from 1 to 2 of x squared minus x dx, it's the same function. But our bounds are different. So from 1 to 2. So we're going to plug in our upper bound first. We get 2 cubed over 3 plus 2 squared over 2 minus 1 cubed over 3 plus 1 squared over 2. It should be minus. I just changed it. Minus, minus, minus. So we get 8 over 3 minus 4 over 2 minus, okay, we did this before, but it's 1/3 minus 1/2, so it's -1/6. And if I just subtract all of this in my calculator to save a little bit of time, I get 5/6, and it should be positive because we saw in our, when we graphed it, that this region is above the x-axis. So then when I do the area, going back to kind of the formula, I'm doing this area or this integral, which is -1/6, and taking the absolute value of it and adding then the second integral from 1 to 2. So it'd be the absolute value of -1/6 and 5/6. So that's 1/6 plus 5/6. Which is 6 over 6, which is 1. So that would be my area. So just to show you in the calculator, so I will show you the definite integrals in the calculator. However, on the exam, you are going to be asked to do all these by hand. So it's a good way to check it, but if you do this, you will not get full credit. So what you do to do it on the calculator is you click on math and you scroll down to F int. Let me get out of the table. So math, F int. Now I have a newer operating system, so this shows up. If it doesn't show up and it just says F int, I'll write out how you'll put it in after we do this one. So what you're gonna do, if I'm doing this integral from 0 to 1, I would do 0 and then 1. I put my bounds, I put my curve. So x squared minus x. You put the original curve, not after you take the antiderivative. It's always the original because your calculator is going to do the antiderivative for you. So do not put the x cubed over 3. You'll get the wrong answer. Okay, so we put the original function dx, hit enter. This gives me a decimal. You can hit math and then frac, so enter, and it'll give you the -1/6. I can hit second entry to pull it. I can click on this and hit enter to get that back up if I don't want to rewrite it all again. And then I can do my bounds from 1 to 2. And then math fraction. So again, I get 5/6. So that's like a shortcut to do integrals or in order to check. But again, you will be asked to do always by hand on the exam. So you can use it to check yourself, but you need to do the exam. Now, one thing I just wanted to show you is that if you did the whole integral, so math, again, it's number 9, F int, and I just did from 0 to 2 and put my curve x squared minus x. Okay, and then you have to put in the dx and hit enter. I am going to get 2/3 and not the 1 because again, it's doing -1/6 plus the 5/6 instead of making this positive. So that's how you do area between the curve and the x-axis.